We are going to learn about log functions. So we're on 4.2. This is part 1 of 4.2. And this is just converting from log to exponential and from exponential back to log. So this is part 1. Just these two. So we'll look at the other ones tomorrow. Okay, so a log function is the inverse of an exponential function. So it tells us we have to have x greater than 0 and b greater than 0, where b does not equal 1. And here are the two equivalent functions. Log base b of x is equivalent to b raised to the y equals x. If you've taken pre-cal, you've already seen this. If you haven't, then I don't think you see it in Algebra 2. I think it's a pre-cal skill. So the function f of x equals log base b x is a log function with base b. So b can be any value. So we are going to convert from log to exponential. So the way we do this is start with your base, and we're going to draw some little circles here. We're going to go from b over to y. So that's b raised to the y equals, and then go back to the x. So when you're converting, you can use these, this way of moving your pencil and writing the little curves in order to convert. So see how this is the same as that? So here's our log form, here's our exponential form. We're going to convert between them. Okay, so then let's say we have exponential form. We're going to convert it to log form. So we take our base. We're going to go to the x. And then from x to y. So this is log base b of x equals y. So b goes to x, x goes to y. And then on the other form, you go from b to y, y to x. So you're always starting at the b. So on this one, we started at b and went to the other side of the equal sign and then came back around. On this one, we started at the b, went to the other side of the equal sign, and then came back to x. So here is a log form. Let's say it doesn't have a base. Anytime there's not a base, then we say that that base is of 10. So no base, you put a 10 there. So then going from our base, our b, to the other side of the equal sign, so that's 10 to the third power, and then equals 4x. 10 to the third power equals 4x. So we're going to be able to evaluate these and find out what x equals. So if no base is written, you can assume it's a common log with base 10. So we're going to do some conversions over here. So we start at the base. We go to the other side of the equal sign. So we're converting from log to exponential. So that'll be 7 to the third. So the base is the base of the exponent. The number on the other side of the equal sign is your exponent. And then you're going to take that and go back. Equals x. That's the equivalent exponential form. So you're always starting at base b. So here we have base b. We're going around to the other side. So that'll be b squared equals the other number 25. We're not actually going to solve it. We're just learning how to convert it. Okay, we're still doing the same thing. We started at our base, go to the other side equal sign. So we write that as 4 raised to the y equals 26. Okay, so that's going from log to exponential. Now we're going to go from exponential to log. You start at base b. So the base of a exponent is like this, 2be, and then we're going to have to convert that one. But this would be, start at the base, go to the other number. So it's going to be log base 2 of x, because 2 is our base. And then over to the other side equals 5. Okay, let's keep on going. Log base b of 27 equals 3. E is our base, so it's going to be log base e, 33 equals y. Okay, so we've got to do something here. This is not written in exponential form. How do we convert this to exponential form? Y'all remember square roots? Like if I have a square root of 5, we can convert that. So this is squared, this is to the first power, to 5 raised to the half power. These are equivalent forms. So if this is the cube root of 125, I can rewrite this as 125 to the 1/3 power equals 5. So now we can do log base 125 of 5 equals 1/3. Okay, so we know how to convert. We are going to solve them also, which is evaluate. So this is also included in part 1. And I think using basic is too. Sorry, I didn't realize. Look at all of those. But now that we know how to change, we can evaluate them. Okay, log of 100. So there is no base. So what is the base? 10. So let's rewrite this. So this is going to be equals x, because we don't know what it equals. We're trying to find it. So we can go from 10, the base, to the other side. So 10 raised to the x equals 100. So what does x equal? 10 to the what power gives you 100? Second. So x equals 2. So log of 100 equals 2. We can do that in our calculator. Log of 100 equals 2. But when we have a different base, we've got to do something different there. So let's go ahead and look at it this way. So 5 raised to the x power equals 1 over 25. 1 over 125. We've got to get these equivalent. Yeah, negative, because what does a negative power do? Yeah, it makes it as a fraction. So I could change this. So this would be 1 over 5 to the 3rd, right? Which to get it up to the top, which would be 5 to the negative 3. So you're looking for equivalent measures. So then x equals -3. Okay, let's do the next one. I'm going to put equals x. So 36 raised to the x equals 6. What can I do to 36 to make it 6? Divide by 6, or what's to a certain power? To the half, because that's like square rooting it. So 36 to the half power gives us 6 because it's square root of 36. So then x equals half. Whenever you do this on Pearson, you'll just write the solution. You'll say equals half because it's not written as an equation. Okay, let's evaluate these. So I'm going to say equals x. So we're doing the same thing. So we're going to start at the base, go to the other side of the equal sign. So 3 raised to the x power equals 7 square roots of 3. Or the 7th root of 3. There we go. I need to rewrite this as 3 to a power. 1/7. So then the solution is 1/7. Okay, the next one, 6 raised to the x power equals 1 over square root 6. So we want to write this as 6 to a certain power. Well, we know this would be 6 to the half, right? Because square root is to the half power. Now, how do you take it up top? Yep. 6 to the negative half power. So then x is going to equal -1/2. Okay, there are certain properties that we can use. So look at how this has log base b of b. It equals 1. B must be raised by b to get b. So if you look at it, b to the first power equals b, right? So then it just equals 1. If we have b log base b of 1, b raised to the 0 power gives you 1. So anything to the 0 power is going to equal 1. So if you have a log that says equals 0, then you know that 1 is right here. And b can be any number because any number raised to the 0 power equals 1. Okay, so look at this. This has a base log of 9, log base 9 of 9. That's going to equal 1. Because 9 raised, let's just say we have equals x. So that'd be 9 raised to the x equals 9. Then that means x has to equal 1. So our solution is 1. And then a log base 8 of 1. Anytime this number is 1, then that solution is going to be 0. So log of 8, 1, log base 8 of 1 equals x. So it's going to be 8 to the x power equals 1. The only way to get The only exponent that'll give you an output of 1 is 0. Okay, inverse properties. So b has to be greater than 0, and b can't equal 1. So log base b of b raised to the x equals x. So these are the exact same. Your output is going to equal x. Because if you were to go b raised to the x equals b to the x, so just x equals x, these two values are going to be equal. When those two values are equal, the exponent and the output are equal. Then if you have a base raised to a log power, it's going to equal x, whatever that value is over here. Those two will be equivalent. B raised to the log with base b of a number equals that number. So we'll look at these examples. So I'm going to say equals x. So start at the base. So that's 7 to the x power equals 7 to the 8 power. So then 8 has to equal x. Okay, so equals x. We're going to do the base raised to the x. Log 3 of 17. Then we'd actually have to do it again, which is kind of weird. So equals y. 3 raised to the y equals 17. So it says it equals the x value. So the x value is 17. So x equals 17. All right, so that is all for these notes. Make sure y'all work out all the problems for your Pearson assignments.